Alright, in this video we're going to look at the half-life practice worksheet. Up at the top here I'm going to give you a little bit of information that will help us answer all of these questions. So the half-life equation is NT equals NO 1/2 to the N power. Okay, the NT is equal to the ending amount NO is whatever you're starting with. So if you're starting with, let's say, 5 grams of an amount, that would go for NO. N is the number of half-lives. So I might actually think I have enough room here to write this in. So for the number of half-lives, we're going to take the total amount of time that passed, and we are going to divide that by the half-life. Okay, and just in case you weren't here that day, half-life is the time it takes for a radioactive nuclei, to decay to 1/2 its original mass. All right, so let's take a look at a couple problems. Now there are a few different ways that we can solve these. We can make a table, or we can use the half-life equation. I'm going to approach a couple of these problems both ways so that you have experience doing both. So for our first question here, it says the half-life of iodine 131 is 8.04 days. How much of a 150 gram sample would remain after 40.2 days? So for this first one, let's go ahead and let's just do a table. So I'm going to make a table with the mass and then the time. And I'm going to need some room here. All right, and I'm going to make some columns. Okay, now on the bottom, we're going to write in the half-life, sort of. Our time's always going to start with 0, and then we're going to add a half-life every column. Each column represents a time interval. So the half-life is 8.04. So from 0 to 8.04, I added 8.04. To go from my second column to the third column, I'm going to do the same thing. I'm going to add 8.04. So here this will be 16.08. And I'm just going to keep repeating this process a couple times. Now I happen to know how many columns there's supposed to be because I have the key in front of me. But if you didn't, you could go out a couple of columns. My computer does not want to cooperate this morning. You could go out a couple of columns and see if you have enough, and if not, you can always keep adding. Okay, on the top, we're going to write in our original mass, which is 150. Each column I'm going to divide by 2. So 150 divided by 2 is 75. And again, I'm going to repeat the process, divided by 2. 75 divided by 2 is 37.5, and I'm just going to keep going here. Half of 37.5 is 18.75, and then 9.375, and then 4.6875. Okay. Now the question wanted to know how much of the sample would remain after 40.2 days. In this case, I've got up to 40.2 right here, so I'm just going to look at the mass that's there, and my answer would be 4.6875 grams. And that's my answer for the first one. So let's take a look at a couple more. Now for this next one, I'm going to grab a calculator and I'm going to use the half-life formula, so stand by. All right, we are ready to rock here. So I've got my calculator. So for this question, I'm going to go ahead and I'm going to write down the half-life formula again. So NT equals NO 1/2 N. Okay. Our starting amount, which is our NO, is 165 grams. And we need to find N. N is the time passed over the half-life. Let's try that again. Half-life. Okay. All right. Now, the amount of time passed, it says, is 90 minutes. That's the total amount of time that passed. And my half-life is 18 minutes. So I'm going to do 90 divided by 18. It's too early in the morning for me to do that in my head. That is 5. So I'm going to write out my half-life equation with everything I know. NT equals my original mass, which is 165, 1/2, and then N is 5 in this case. So I'm going to go ahead and punch this into my calculator. 165 times 1/2 to the 5th power gives me 5.15625 grams. All right, let's keep moving on. For some reason, my screen is cut off here. Let me try doing this again. Nope, doesn't want to cooperate. That's fine. We'll just keep working with this. All right. I personally think the half-life equation is easier, but again, if you want to do tables, you can do tables. There are some situations where tables won't work if all of the information isn't there. Sometimes you have to use the half-life equation. Okay, for number 3, let's go ahead and let's do another table, just so you're familiar with the process. So I'm going to write mass at the top, and then time is going to go at the bottom. I'm going to extend my table out. Okay, not sure how many columns I need, but I know I need to go up to 133.5 days. So let's start our time at 0. Our half-life is 44.5 days, so each time I go forward a column, I'm going to add 44.5. So again, plus 44.5 each time. And then I'm going to do it again, plus 44.5. This is going to be 89. And then if I do it a third time, this is going to be 133.5. Okay, and that's actually where it tells me to stop, so I'm good. I'm going to put my starting mass in here, which is 2 milligrams. 2 milligrams. Half of 2 is 1. Half of 1 is 0.5, and then 0.25. Okay, so the question wants to know how much is left after 133.5 days. The answer is 0.2525 milligrams. Okay, let's take a look at number 4. Number 4, let's go ahead and use the half-life equation if we can. So let me write that out. NT equals NO 1/2 N. First step is going to be define N. N is the time passed over the half-life. Half-life. Okay, the time passed, it says, is how much remains after 9,600 years. And the half-life is 1,600 years. Okay, so I'm going to do on my calculator 9,600 divided by 1,600. and that's going to be 6. So my N is 6. Now it's just a matter of plugging in what I know. NO, our starting mass, 20 grams, times 1/2 to the N power. So let me do this on my calculator. 20 times 1/2 to the 6th power is 0.3125 grams. Okay. I'm going to do one more with the table, and then I think for the remainder of these, I'm going to do the half-life equation, just again, because that's my personal preference. I feel like the table is kind of self-explanatory. You just list everything out. So let's do one more with the table. So for number 5, I'm going to write mass. I guess computers don't work this early in the morning. It is 6:17 in the morning, and I am just fired up and ready to do some science this morning. All right, so I'm going to make a couple columns. Again, I kind of have the advantage of knowing how many are supposed to be there. So on the bottom, we're going to add the half-life each time. So here, again, I'm adding 15. Here, I'm adding 15. So 15 and 15 is 30, then 45, then 60. My starting mass goes on the top, 208, and then I just take half of that each time, so I'm dividing by 2. Half of 208 is 104, and then 52, 26, and 13. So my answer in this case, it says after 60 hours, my answer will be 13 grams. Again, whatever you think is easier. If you're good with the table, do the table. If you prefer to do the half-life equation, do the half-life equation. For the remainder of these, I think I'm just going to go ahead and do the half-life equation. I've written the half-life equation out a couple times, so I'm just going to go ahead and plug in what I know here. I know for my half-life equation, I always need to start out by finding my N value. So N is the time passed, which in this case tells me is 24.3 days. And my half-life is 8.10 days. So on my calculator, I'm going to do 24.3 divided by 8.10, and that gives me N value of 3. So my half-life equation, NO, my starting amount is 50 grams times 1/2 to the N, which is 3. So on my calculator, I'm going to do 50 times 1/2 to the 3rd, which is 6.25. Okay. Number 7. Same thing, I'm going to start by finding my N value. Time passed is 8,000 years, would remain after 8,000 years. And my half-life is 1,600 years. 8,000 divided by 1,600 is 5. And I will plug into my half-life equation. My starting mass is 8,000 grams times 1/2 to the N, which is 5, as we found out. So on my calculator, 8,000 times 1/2 to the 5th gives me 250 grams. All right, I think I have 2 more here. Okay, so number 8. Again, let's start by finding N. We've got, let's see, after 62 hours, so 62 hours is my time passed. My half-life is 12.4 hours. Let's try that again, 12.4 hours. So 62 divided by 12.4 is 5. Plugging into my half-life equation, my original amount is 848 grams. And I'm going to multiply that by 1/2, and then my n value is 5. So 848 times 1/2 to the 5th power is 26.5 grams. I don't think I mentioned this earlier, but your ending mass is always the same units that what you started with. So if I started in grams, I'm going to end in grams. Okay. For this next one, let's see. For this next one, it tells us the half-life. It does not tell us the time passed. So this one is more of a conceptual question. And we want to know, how old is a fossil bone if it contains 25% of its original mass? So rather than starting with the mass on top, I'm just going to write this as a percent. So the amount in terms of percent on the bottom will still be time. Time's always 0 when we start. We don't know the mass, but we do know that when we start, we have 100% of the mass. After one half-life, we're going to have 50% of our original mass. I'm going to add a half-life again, and this will be 11,460, because again I'm adding 5730, and I did the same thing here. Okay, so half of 50 is going to be 25%. So to answer the question, how old is a fossilized bone, I'm going to look at the bottom here. So the answer is 11,460 years. All right. For this one, we do not know the half-life. So again, we kind of have to work backwards here. So it gives us the original mass, it gives us the ending mass, and it tells us how many years took place. So let's do this. Let's make a table with the masses. Our starting mass was 64. The next half-life, our mass would be 32. Okay. The next half-life, our mass would be 16. And then 8, 4, and 2. So each one of these columns, I'm taking the mass and I'm dividing by 2. Now, rather than doing time on the bottom, I'm going to label this the number of half-lives. And you'll see why in a minute. So this is after no half-lives. It's our starting mass. 1, 2, 3, 4, 5. Okay, so the question wants to know the half-life. So I know that I'm having, let me write out my equation for n. N is time passed over the half-life. I'm going to go ahead and fill in what I know. I know my n is 5. There were 5 total half-lives. 12 years passed, and I don't know the half-life. Okay. So if this were an algebra problem, I had 5 equals 12 over h. I could multiply both sides by h, so this would be 5h equals 12. And then to get h by itself, I would divide both sides by 5. So in this case, let me slide up here. H would be equal to 12 over 5, or just 2.4. And since our time passed was given in years, this will also be in years. And that is how to solve all of the problems on the half-life worksheet.